Hello, this is 4.4 day 1, factoring polynomials. So to get started, I want you to go through and solve the following equations. So these are both quadratic equations. This is a review of chapter 3, solving quadratic equations. So pause the video and do these two quadratic equations real quick. So if we look at the first one, we see we can factor out a 3 and an x. That's what's in common in both terms. So we can go ahead and factor out a 3 and an x. So if I pull a 3x, that first term turns into a 2x, and then we're simply left minus 1, and that's equal to 0. So we're going to go ahead and set both of these equal to 0. And here we get x equals 0, because I just divided by 3 there. And then I get 2x equals 1. And then I divide by 2. I get x equals 1/2. And I get x equals 0. Remember, quadratics have two answers or two solutions. So first I need to set this equal to 0. 8x squared plus 4x minus 12 equals 0. Okay, and what's in common here? I can pull out a 4, right? This turns into a 2x squared plus x minus 3 equals 0. Okay, now I see I can factor this, right? I can split this up, 2x and x, and my only option is 3 and 1. So just try 1, doesn't matter, we can try 1 and 3. Here I get 1x and 6x. Anyway, with 1x and 6x, I can get to 1x. No. So then I'm going to go ahead and switch those. 2, 3, and 1. And here I get 3x. Here I get 2x. And that looks a little better, right? We need positive 1x, so I'm going to do plus 3x minus 2x there. Okay, and remember this is set equal to 0. So I set each term equal to 0. And I get x equals 1. 2x equals negative 3. X equals negative 3/2. Okay, and those are my solutions. That was a review of chapter 3. The goals for today is that you are able to factor polynomials. So we just looked at factoring quadratics. Now we're going to go ahead and use those same concepts to factor polynomials. So if we look at the top left problem here, what do we notice? Is there anything in common we can take out? That should always be the first thing we look for. So I'm looking at this equation. I see an x in all three terms. So I'm going to go ahead and factor out an x. And then I'm left with x squared minus 4x minus 5. Now this looks like something we can handle, right? Now we're back to an x squared, and we know how to factor quadratics, so we can go ahead and factor this. An x and an x, split those up, and then I only have one option for 5, so I'm just going to go ahead and do 5 and 1. And that gives me a 5x and a 1x. So how with 5x and 1x do I get negative 4x? Well, I need a negative 5 and a plus 1. So I'm going to go ahead and add in those signs. Remember, this is set equal to 0 as always. Okay, and then typically we would go ahead and I actually goofed. We're not setting these equal to 0. They don't set it equal to 0. So we just want to simply factor. So once we get to this point, we're good to go ahead and stop right there. Our next lesson will actually be solving. So those we will set equal to 0 and solve completely. All right, you have 2 more here. I want you to go ahead and try these on your own. So pause the video, try these next 2, and then go ahead and hit play and review that you did them correctly. Okay, so I see I can factor out a z squared here, right? Z, and the highest, there's a z squared in all of these, so I can go ahead and pull that out. What I also notice is a 5 in common. So I can pull out that. So 5z to the fourth, I pulled out 5z squared. So I'm only left with z squared. And then this will turn to a 6z and plus 9, right? So I factored a 5z squared out of all three terms. And again, now I'm left with a nice z squared, which I can factor. So I get 5z squared, and then this I know what to do with, right? Can split up my z's. And then my factors of 9 are 1 and 9, and 3 and 3. And I'm going to start with the 3 and 3 because I know those add to be 6. I get 3z and 3z. Perfect. And that is my answer. Okay, on this bottom one, I notice m cubed. I'm going to pull out of all of them, but also an 8, right? There's an 8 and then an 8 and 16. 8 times 2 is 16, and then there's also an 8. So I pull that out. I'm left with m squared minus 2m plus 1. Okay, now same concept. I know what to do with an m squared. I can go ahead and factor that. Oh, I'm sorry, this should be cubed here. M and m, and my only option is 1 and 1. Now I need to get to negative 2 with 1m and 1m, so I'm going to subtract. Okay, so what we notice with all three of these is once we pull out that common term, now we're simply factoring this as if it was a quadratic. All right, moving on here to factor by grouping. So what we want to do here, this may be a new concept to you. Factor by grouping, we want to group. We see there's nothing in common with all of these. We can't pull one thing out of all of those. So we're going to group these first two terms and the last two terms. Okay, so if I was only looking at the first two terms, z cubed and z squared, there I do see commonalities, right? I do see a factor of z squared in both of those. So I'm going to go ahead and pull out a z squared. And then in the first term, I'm left with a z plus 5. Okay, now I only did that out of the first two terms. Now I'm going to look at the second two terms. What do I see in there? Well, they both have negatives, right? So I can pull out a negative. And I also see a 4. So I'm going to pull out a 4. And then I'm left with z plus 5. Now we see these are the same, and that's good. That's exactly what we wanted. We want those to be the same. So from here, we can rewrite this. Z squared minus 4, we're going to group that, and then our z plus 5. So what happens here is I factored out a z plus 5 out of both of these. So in this term and this term, what's in common? The z plus 5. So I pull that out, and then what's left? The z squared minus 4. All right, so using that concept, I want you to pause the video and try this second one on your own, factor by grouping. So go ahead and group those first two terms. And what's in common in the first two? A y squared. So I'm going to pull out a y squared, and I'm left with 3y and plus 1. And then I look at my second. What's in common here? I see a 3. And I'm left with 3y plus 1. I see that these are the same, so I know I'm right on track. I can factor that out, 3y plus 1, and I'm left with y squared plus 3. And if I wanted to double check, I could FOIL these back together, and I should get my original. All right, here are 3. I want you to go ahead again, pause the video, and use the appropriate method to factor all 3 of these. Okay, so in the first one, I see an r to the fourth. All right, I'm going to factor out r to the fourth. And now I'm left with 3r squared minus 11r minus 20. All right, now I'm back to a quadratic, and I know I can factor that. So I'm at r to the fourth. I can split up my 3r and r, and I think about 20 and 1. I have 10 and 2, or I have 5 and 4. And like I always like to start with the 5 and the 4, so I'm going to go ahead. 5 and 4. I get 5r and 12r. Anyway, with 5 and 12, I can get to 11. No, so then I'm going to switch them. Before I move on, 4 and 5, and I have 4r and 15r. Now I see I can get to 11 by negative, or I need a negative 11. So I'm going to have negative 15 and a positive 4. And there it is, factored. Okay, and then same idea with the second one with the p's. I'm going to factor out a p squared. I see there's a p squared in all of those terms. That's the one most obvious to me. And now I also see 15 and 18 are both divisible, and 3 divisible by 3. So I'm going to pull out that 3, and I'm left with p to the 6th plus 5p to the 3rd plus 6. All right, now you're like, well, I don't know what to do. This is to the 6th. We're going to use the same concept as if it were a quadratic. So we're going to factor like it was a quadratic, okay? So we know p to the 6th can be split up as p to the 3rd, p to the 3rd, right? 3 plus 3, that gives me the 6. Now I'm going to split up my 6. My options are 6 and 1 or 3 and 2. Again, I'm going to use 3 and 2. And same idea, we still need it to add to get to 5p cubed. Here I have 3p cubed and 2p cubed. Well, if I add those, I get to 5p cubed. So it's the same idea as if we were factoring quadratics. All right, on the last one, I see there's nothing in common that I can pull out of every single term. And there's 4 terms, so I'm going to go ahead and factor by grouping. All right, and the first one, the thing that pops out to me is a k squared. And I also see a 2, so I'm going to factor out 2k squared, and I'm left with k minus 10. All right, and the second one, what pops out is a 5. So I'm going to factor out 5, and I'm left with k minus 10. Again, these are the same, so I factor those out. And I'm left with 2k squared plus 5. All right, our last page here, determine if the given binomials are factors of the polynomials. So to determine if something is a factor, we want to use synthetic division. So this will be a good review of synthetic division for us. So go ahead and set synthetic division using these coefficients. Notice we're missing that x term, so we need a placeholder that's 0. All right, and I'm going to be dividing by x plus 5, so it would be x equals negative 5, right? So we're going to put a negative 5 here. And then that 3 goes down. 3 times negative 5 is 15. Negative 15. Add to get 0. And then 0 times negative 5 is 0, so I get negative 1. Negative 1 times negative 5 is 5. 5 times negative 5 is negative 25. I get a remainder of 0. So if I get a remainder of 0, write this down. Remainder of 0 means yes, it is a factor. Okay, so that's how we can determine if it is a factor, if we use synthetic division and get a remainder of 0. Okay, so now I want you to go ahead, pause the video, and try this second one. So I'm going to go ahead and set up my coefficients, 1, 2, 4. We're not missing any terms. This would be a 2. So I bring down my 1. 1 times 2 is 2. I add to get 4. 4 times 2 is 8, right? And, this should be negative 4. Negative 4 plus 8 gives me 4. This is my remainder, not 0, so no, not a factor. And this one was yes. Yes, it is a factor. All right, that's all we have for today's lesson, 4.4 day 1 of factoring polynomials. If you have any questions, as always, please reach out and I'd be happy to help. Thanks. Have a great rest of your day.